All right. Hello, hello, hello. I think it's recording. Yes, it is. For today's class, we are going to be talking about quadratic functions. We've already looked at equations that are quadratic. We know when something is to the square, then we know that's a quadratic function. We know what they look like. Okay. Today, we're going to look at factoring quadratic functions when it's not equal to the zero or when it is, but also how do we solve these equations. We're also going to look at when the coefficient is not a 1 versus when the coefficient is a 1. We have a good bunch to get through today, so let's get it going. For our success criteria, it states, I will be successful when I can factor a trinomial with or without a leading coefficient. One more success criteria that should be on there. That word is so hard to say, success. Success criteria. One more thing that should be on there is when the quadratic is not equal to 0 as well. Just to review a little bit, if we were given one of these and we're asked to simplify, we know we do each term and we multiply by each term in the other one. K times k is k squared, and then that's going to give us a negative 5k plus a 1k minus 5, and then you group your like terms, so you end up getting something that looks like k squared minus 4k minus 5. That's just a quick review. Now let's look at what if I gave you this quadratic right here, and I said to factor this quadratic. We're gonna have to figure out a way to factor this quadratic easily. This is what we're doing today. So I'm going to show you two different ways. All right. The other way that I do it is a trial and error, but the more you practice this, the easier it's going to come. So with something like this, what I want to do, I want to find two numbers that multiply to get 5 or negative 5, but add to get negative 4. So we look at this part first, realize whatever number is here, whatever number is at this portion right here, we need two numbers that multiply to get that. And those two same numbers have to add up to get negative 4. And we've already kind of done it. It was up here. It's 1 and negative 5. If we multiply 1 times negative 5, we get negative 5, right? But if we add them, we get negative 4. So the two numbers, whatever two numbers you pick, that's how we start. We pick those two numbers. We pick those two numbers. They have to multiply to get this last number right here. And then you have to add them to get this number. Whatever those two numbers are, that's what you use. So then once we've figured out what those two numbers are, which we've figured out that it's 1 and negative 5, then we do a thing like this. The first method, which is the easiest one, we go ahead and we write our two parentheses. Since the variable is k, we put k. And then we said that it was plus 1, positive 1, and negative 5. And then that's our answer, period. So it kind of brought us back to where we were up here. That's just a straightforward, easy answer. That's when we're asked to factor this quadratic. So that's how we do that. We get two numbers, multiply them, and then add them to get this middle part right there. Or we could do, I like this way because this way is very transferable with the next thing we're going to do. So we do k squared plus 1k minus 5k minus 5. Instead of putting negative 4k, I put 1k minus 5k, which is negative 4k as well. Do you see that? So the two numbers I picked, 1 and negative 5, I just separated the 4 into 1 and 5k. Now I just have to factor. So I look what the greatest common factor is between k squared and 1k. What is the greatest common factor between k squared and 1k? K. Yeah, 1k. 1k or k. So once I do that, then I open my parentheses and it leaves me with k plus 1. That's that first part. Now I look at this part. What's the greatest common factor between negative 5k minus 5? Negative 5. Which gives me k plus 1 left, right? Negative 5 times k is negative 5k. Negative 5 times 1 is negative 5. Do we realize that these two parts are the same? So then what I do, I take the outside coefficient numbers variable, which is k minus 5, k minus 5. And then I just put back, since these two are the same, I just got to write one of them. Which gives me back exactly this answer up here. So this is just another way you could do it. Yeah, this way up here, you find the two numbers that multiply to get negative 5, and then add, and then you just put them in your parentheses like that. That's one way. We also want to look at what if my, so k plus 1, k minus 5, what if my equation was equal to 0? Right now it's just an expression and it's asking to factor it. What if I get something that is k squared minus 4k minus 5 is equal to 0? And then it says, what are the values for k? So in order to solve this, you know, like we'll get a regular equation, we say 2x plus 3 equals 0, and we go through, we find x and let x be by itself and whatever x is. With this, in order to do this, we have to factor first. And we factored it, and we already know that it's going to be k, what we say it was? Minus 5, k plus 1. But this is equal to 0. So now we need to figure out what the values for k are. So then all we do is k minus 5 equals 0, and k plus 1 equals 0. K is equal to 5, and k is equal to negative 1. When you do the additive inverse and everything, you bring it to the next slide, you figure out what the values are. K squared is telling us that there are two values for k. So at the end, we end up getting two values. A quadratic graph looks like a U, right? And we also have to remember with a quadratic graph, how many times does it pass the x-axis? So let's put a graph thing right here. So the U, right? How many times does it pass the x-axis? This is the x-axis. Twice, which tells us there are two values. So with these questions now, we're going to talk about the quadratics where the leading coefficient is not a 1. In this case, it's a 2. We're going to talk about the leading coefficient is not a 1. In this case, it's a 2. In order to solve these, the easiest way I could think about is you take these two numbers, the constant and the leading coefficient, you multiply them. So you take the leading coefficient and the constant and you multiply them. So you get 6. Now my job is to figure out what two numbers I can multiply and get 6, but add them and get 7. What two numbers can I multiply to get 6, but add them and get 7? 1 and 6. 1 times 6 gives us the 6. Well, 1 plus 6 is 7. So then I take my 1 and my 6, and then I separate them. 2x squared plus 1x plus 6x plus 3. So all I did again was separate the 7x into 1x plus 6x from the 1 and the 6 that I figured out. Then now I do the greatest common factor. I do the greatest common factor. I'm going to change my color for this part. 2x squared and 1x. What's the greatest common factor between 2x squared and 1x? It would be x. So x on the outside, which leaves me with 2x here, and then plus 1. Now I'm going to go to the second part right here. What's the greatest common factor between 6x and 3? The greatest common factor between 6x and 3 is just 3. And then if we've got to look what's left, if we take the 3 out of the 6x, we're left with 2x. And then 3 times 1 would give me back the 3 up here. So then, just to recap, I take the first two numbers and I do the greatest common factor stuff we were doing. Then I take the next two and then I do the greatest common factor again. Then you realize that these two parts are the same. So then I take my two greatest common factors, so x and then plus 3. Put that in parentheses. And then since these two are the same, I just put one of them. And just to recap a little bit, if this was equal to a 0, then we would solve and find what x is, find what x is. One more thing that we're going to look at, which is kind of similar to everything that we've been doing. What if there's an n squared plus 7n plus 15? This is equal to 5. We've been solving problems where it's equal to 0. So what we're going to try and do is have this equation equal to 0. So this right here is equal to 5 right now. We don't want it equal to 5. We always want it equal to 0. So I just need to move it to the next side. So since this is a positive 5, I'm going to subtract it from both sides. So then now I'm left with n squared plus 7n plus 10 is equal to 0. If it's not equal to 0, we want to change it so that it's equal to 0. And then you'll go through with this two numbers that multiply to get 10, but add to get 7. We just did 5 and 2, positive, and you always put back your variable. And then you'd go through n equals -5, n equals -2. That was a very, very good question. The question was asked if it matters what order these are placed, then it's not, it doesn't matter because they're multiplying. 1 times 3 is the same thing as 3 times 1. Okay. We're going to do one more question and then we're going to call it quits. The assignment is already posted. Let me know if you have any questions, comments, concerns.